Hi everyone, Steven here, and welcome to another lecture in the MATLAB Crash Course series. So today we're going to be looking at an introduction to plotting and file input with MATLAB. So some of the topics we're going to cover today. So first we're going to look at using the plot function in MATLAB to easily create two-dimensional plots or graphs. We're going to take a look at customizing these plots using specific characters or different functions in MATLAB. We're going to take a look at plotting multiple curves at once, basically on the same graph. We can plot more than one function or more than one curve. We're going to take a look at file input with a .dat file or a data file and how MATLAB uses these files to store numbers or data. And then we're going to be using a .dat file for plotting ourselves. So let's get right into it. So first, using the plot function. So MATLAB is a very useful programming language as it specifically has a set of multiple functions to allow for easy plotting. This is what gives MATLAB in this area specifically a little bit of an edge compared to C, Java, Python. Those programming languages sometimes makes it a little difficult to plot. Or for Python, you need to download extra packages or libraries to plot. But with MATLAB, everything you need to plot is right there. In fact, it's a very simple function, plot. So the plot function can be used to plot basic two-dimensional graphs, and it's very straightforward. And here's the standard form generally for a plot function. So you'd be typing plot, and then you would type your x-coordinate or your x-coordinates, and you can enter an axis in here, or not an axis, a vector in here of x-coordinates. You could enter a vector of y-coordinates, where essentially every single corresponding x and y pair are the two different components of our vectors. So for example, well, I'll give more examples later, but so if I had 10 points here for my x-coordinate, I need 10 points here for my y, because every single x needs a y-coordinate. So those are the first two inputs, and the third input is a customization character, and we're going to look a little bit more into that, but it's how to make your plot look a little bit nicer, how to change it a little bit if wanted. So let's see, the plot function can be used to plot basic two-dimensional graphs. We already looked at that. Essentially, we can look right here. If we looked at this example, plot 3, 4, and then an asterisk would plot the point 3, 4 on a two-dimensional plane. Now, this customization character is optional, but in this case, we do need it or else nothing would show up. And I can actually do this right on the command line. I actually have it pulled up right now. Let me clear this out of the way. So if I actually just go ahead and I don't need to do this in the editor. I can just go right here, plot 3, 4, the asterisk, and then you'll see right here that we actually have a point plotted at 3, 4. So this is our x-axis here, this is our y-axis. MATLAB makes it very nice. It chooses our axes actually automatically, and we can customize these. I'll show you in a second. But they have a cool few features up here that we can actually use. So if I click this is a pan feature on here. See, my icon turns to a little hand. If I press and hold on my keypad, I can actually move around. This is what makes MATLAB kind of nice, is it automatically gives you some features where you can kind of analyze or look at whatever you plotted. This is a rotate feature where I can actually rotate what my graph looks like or kind of make it three-dimensional. We're not going to be using these too much in this video. This would be more useful for three-dimensional plotting, which is something that might be covered in a later video. This is just kind of to show you what all this is. Right now, this is actually the z-axis now, and this is our x-axis, so we rotated it. Let's see what happens if I didn't use that asterisk like I was talking about. If I just said plot 3, 4, MATLAB will think that I'm just trying to plot a line, but for a line you need 2 points. So it won't actually appear with anything. So if you want to plot a single point, you do need this character here, the asterisk, or another type of character. We'll get into that later. But we're not really going to be looking at just plotting 1 point, so that's not going to be too useful for us. But so, like I said earlier, MATLAB will automatically choose the best axes to plot, but the axes can be specified using the axis function. The way you use the axis function is you have to enter a row vector in here, and you put you put 4 numbers in that row vector. You put the x minimum, or the minimum value for your x-axis, x max, maximum value for x-axis, y minimum, y maximum. So your minimum values for y and your maximum value for y, min value for x, max value for x. Very straightforward. We'll do an example. We can do an example in a script actually. And I have it shown up. I have it actually up here right now. So I could say plot 3, 4, and then I could say axis. This is just a script I made, example plot. So for my axis, I could specify it to be -10 to 10 for my x min and x max. For my y min, we can do -10. And for my y max, we can also do 10. So I enter 4 values to say, okay, this is the minimum value for x, maximum value for x, minimum value for y, maximum value for y. If I run this, you'll see it's actually changed a bit. So my minimum is -10, my max is 10, -10, 10. So if we look here, 3 on my x-axis is here, 4 on my y-axis is up here. So this is where the point actually exists. It's just something if you want to customize it or if you want to specify your axes, that's how you would do so. A curve can be plotted by inputting an x vector and a y vector for the inputs of the plot. So we just looked at entering single numbers. We can actually put an x vector and a y vector, so row vectors of values, and MATLAB will plot these instead, and it will plot the multiple points together, and every point we plot on there will be connected by a line in each one. And I'll show you an example. So here we say we're going to plot the points 1, 1, 2, 4, and 3, 9. If you look at these points, this has a if the first value is x, the second value would be x squared, because 2 squared is 4, 3 squared is 9. So we'll take a look at this, and we can use this function right here to actually plot these points. You'll see we say plot 1, 2, 3, because those are our 3 x values, and 1, 4, 9, because those are the corresponding y values. So we don't keep the x and y together, we actually split them up, but we need the order to be right, or else we'll be plotting different points. So let's actually try this. I could say plot. For my first one, it'd be 1, 2, 3. For my second vector, it'd be 1, 4, 9. Oop, not 98. So let's see what happens here. So you can see here, we actually ended up plotting this. If you look, our first point is 1, 1. MATLAB automatically chose this to be the minimum for our x-axis because that's just where the first point is. It makes most sense. We see everything. So we have 1, 1 here, then 2, 4 is right here. You'll see there isn't a curve connecting it as the y equals x squared function would commonly have. Instead, what they do is they take their points and automatically create the line of best fit in between those right away. So here we have 1, 1, 1, and 2, 4, and right in between those we have a straight line. Then right here we have 2, 4, and here we have 3, 9, and there's automatically a good fit right there. You'll see they have the scale a little bit different. So here we have 1, 1.2, 1.4 for the x-axis. For the y-axis, it's 1, 2, 3, 4. This is just to make it so that you see exactly what you want to see, exactly what you plotted in the most convenient way, manageable. And so that's what makes it, if you want to make something look more accurate, you need to specify multiple different points. So if I actually wanted to plot y equals x squared, I need to give a lot more points than just 3, because as you can see, giving 3 points just makes it 2 straight lines essentially, and it doesn't look like y equals x squared. We'll do an example showing this a little bit later, but for now we're going to continue and look at customizing plots. So if points are to be plotted instead of a curve, so for example, we looked at a curve being plotted where all the lines were connected. Let's say we just want to plot the points. We don't want any lines connecting these at all. One can specify this by using a customization character for a third input for the plot. So plot x comma y with an asterisk. We'll plot the curves using asterisks. So let's do that last example again. So I'm going to do this example again, but as a third input, I'm going to put the asterisk that we saw earlier. And let's see what happens. So as you can see here, it actually gave me 3 different points. It might be hard to see. You can see that one. There's another one right here because that's where 1, 1 is. There's another one right here because that's where 3, 9 is. Instead of drawing the line in between it, it actually just gave me the 3 points. And so we can actually do multiple different things with this. We don't need it to just be an asterisk. There are multiple different options. We have the asterisk. There's an O for a circle, an X for an X, plus sign for a plus. I put the asterisk in here twice. So the asterisk is just an asterisk. It's not special enough to be there twice. S stands for square. D stands for diamond. The V stands for an upside down triangle. The caret stands for a right side up triangle. The less than sign stands for a right triangle. A greater than sign stands for a left triangle, so the triangle's pointed in a certain direction. The P stands for a pentagon, and the H stands for a hexagon in this case. We can do a separate example besides, let me exit out of this. We can do a separate example besides the asterisk. So let's say I want to make it a square. I put an S instead. So you can see now little blue squares popped up. Blue's the default color right away, but we can actually specify what color we'd like by using another customization character. So the color can be changed by adding another character to the input. So for example, plot x comma y, and then b plus will plot the curve with blue plus signs. Blue's the default color, so let's not do blue. The other examples are blue, G for green, R for red, C for cyan, M for magenta, Y for yellow, K for black, and W for white. White will probably not be too helpful in this case. Let's try green. Let's do green plus signs on here. So I could say plot, and I'll say G plus for green plus signs. So you'll see here, ooh, it's a very light green in this case. It might be a little tricky to see. Let's try a different color in this case. Let's try the magenta. So we'll try instead M plus. So now these are magenta instead. You'll see little magenta plus signs for our points. It's just a cool little feature MATLAB has to give a little more customization. choose points to be however you want to be, different colors, different options. There are many other functions that can be used to enhance the plot. So for example, we have a few functions to make things look nicer. So we have xLabel function will create a label for the x-axis. The yLabel function will create a label for the y-axis. The title function will create a title for the plot. The legend function will create a legend for the plot, and we're going to look at this in a separate example. We're not going to deal with legend right now. And grid on, if we type grid on, we'll place a grid in the background of our plot. So these are just some other functions we can use to make it nicer, give it a title, give it the x-axis a label, give the y-axis a label. All this stuff is used to make our plot look nicer. And I'm not going to do these right away, but we're going to show how these work in this first example here. So example 1, create a script that will plot sine of x from 0 to 2 pi in red using, and they give us different points we're going to use here. We can do it in 10 points, 20 points, and 50 points. We're going to do each of these one at a time real quick. So I'm going to, let's clear this real quick. And I'm going to make a new script for this. And let's save this script as plot sine, because we're simply just plotting the sine function. So let's see how exactly this would pan out. So let's start by giving a comment. Plots the function y equals sine of x. Simple as that. That's all we're going to do. So the first thing we're going to do here is we're going to define our x and y axes. So let's define them. So what would x be in this first case? So what we want to do is we want x to be from 0 to 2 pi using 10 points. So since we're trying to make, in this case, and trying to make a vector here, because remember, to give multiple points, you have to enter it as a vector. So to give multiple points or multiple vector, I could try typing a long axis. I could say, okay, 0 to 2 pi divided by 10. All right, that means I need to go from 0 to pi over 5 intervals, and I need to type out 10 numbers. But that's a little tricky. If you remember back in one of my previous videos, I believe lecture 2, where we talked about how to create vectors in MATLAB, we can actually use a specific function to make this a lot easier for us. And this function, if you remember, is called the linspace function, where it will automatically separate 2 points into multiple different values in a vector. So I could say, all right, linspace, my lowest value will be 0. My highest value will be 2 pi, so 2 times pi. And then I want there to be 10 points, so I'm going to enter the value 10. If you don't remember exactly how the linspace function works, I would recommend typing help linspace here on the command window, or checking out my other MATLAB lecture video, I believe it was lecture 2, where we talked about an introduction to matrices and vectors in MATLAB. So this is how we made our x-axis here. If we actually, let's actually type what this looks like here. So I say linspace 0, 2 times pi, comma 10. So it's 10 points that go from 0 to 2 pi, and it's evenly spaced. That's exactly what we want, and that's what we have up here. So let's see, so I have that. What's y going to equal in this case? Well, so we're plotting the sine of x function, so we need to put every single value that corresponds with the single value of x when we plug that value of x into sine. Essentially, we have to plug each of these values into sine and put them all as a vector. What's really cool, actually, is that if we just say sine of the whole vector, it will automatically return a vector giving each of the values of sine for each corresponding x value. So let's see, this value right here, this vector is saved as answer right now. If I say sine of answer, it's actually going to give me the sine of each of those values, and they actually work exactly the way we'd want it to. So sine of 0 is in fact 0. The sine of, let's see, what's another example? Sine of 0.6981 is 0.6428. That seems reasonable. So all we have to actually do to get the vector we want is literally just say sine of x, because we already have our x-axis defined. So if we say y equals sine of x, y will be another axis where each corresponding x point is the y point for sine of x. So that's all we have to do. So now we have our x-axis and our y-axis specifically defined. Now we just need to plot the two. So I'm going to leave another comment saying plot the function. Plot the function. So in this case, we're going to use the plot function. That's what we've done before. So plot x comma y. So this is our x-axis consisting of this axis here. This is our y-axis where we took the sine of every point in the x-axis. Now the last specification was we want to plot it in red. So the customization character to plot it in red is going to just be the letter R. And that's all we need. So actually, if I run this, this should produce us a plot in MATLAB. So if I run, so this is what our plot looks like. This is using 10 points, plotting sine in red. Now you can see here, this looks very rocky. This doesn't look all too great. You can see exactly where each of the 10 points are. It doesn't look all too nice. It's very jaggy. You wouldn't want someone to turn this in as a plot of sine of x. But we can make it a little bit better, and that's why I give multiple examples. So let's plot it again using 20 points. So instead of saying from 0 to 2 pi 10, I'm going to say 20, because this is instead going to give us 20 points. I don't have to change the y equals sine of x, because x is changed, so y automatically is changed. If I run this, it looks a little bit smoother now. But you can see around up here and down here, it still looks a little pointy, so we want to really eliminate that. So to eliminate it, we're going to increase our point value a little bit more. We're going to do 50 points. So let's change this from 20 to 50. Oops, that's not what I wanted. Let's run it. This looks a lot nicer. This really looks like the sine of x function that you've seen in your calculus or pre-calculus course. This is exactly what we want. So the lesson here is using more points essentially makes your plot look better if you want to plot something very specific. That makes sense. The more data you have, the more accurate you can be. So what we're going to do now is I'm going to give an example of using the other functions we have here, the x label, y label, title, all these functions. Let's see how exactly we do it. So we're still in this example. So I'm going to say customize the plot. And so here we're just going to do some customization. So all you have to do to make an x label or a y label is you just have to use these functions directly after your plot function, and MATLAB will know exactly what you're asking it to do. So let's first define an x label. So our x label in this case, and we need to enter it in apostrophes, is we're just going to say, well, let's call them x values. Well, it's x values. This will just be our x-axis label. It's very just standard, low-key. For a y label, we could just say sine of x. Oops. Sine of x, that's going to just give us a y label just called sine of x. We can give it a title. The title can be plot of sine of x, so people know exactly what we're plotting here. And then just to make it look a little bit nicer and see where our points or lines intersect, let's turn the feature of grid on, and you do it just like this. Let's see how our plot changes by doing this. So now all of our features have been added on at once. We have the x label, x values. We have the y label, sine of x. Our title in bold is plot of the sine of x. And we have a grid in the background. And this grid is showing us the intersection of each of the points we have on the x and y axes. So these features are generally should be used whenever you make a plot to make it look nice so that anyone else who's using this code will know exactly what's being plotted. Alright, I have one more example for us to do regarding this real quick. Create a script that will plot a linear function y equals m of x plus b. Ask the user for the values of both m and b. Plot the function from -10 to 10 in red. Okay, so we have an interesting little thing for us to do here. So we're going to be plotting this linear function y equals mx plus b, but the user can pick what m and b are. This kind of goes back to my previous video writing scripts in MATLAB, because we're going to be using some user input, user output to actually ask the user what they want to be the slope and the y-intercept. So let's create a new script. Let's call this script custom plot. So custom plot.m. So the purpose of this script will prompt the user for a slope and a y-intercept and create the corresponding linear graph. So that's all we're doing in this case. So let's actually get started. So first, ask user for requested values. So first we need to ask the user for the slope and for the y-intercept, because those are the two things you need to make, essentially the two things you need to make a linear graph in this case. So we're going to use the input function. If you don't remember what the input function is, check out my user input and output video on this channel. So what we're going to do here is let's call the slope m in this case, because y equals mx plus b. So m, and then we can say input, enter a value for the slope. That's all we're going to do. So the user can enter any value here, and that value will be stored under m. B can be the y-intercept. So we can say enter a value for the y-intercept. So the user can enter any value they want for the y-intercept. So now we're going to use these values to actually create our function. So if you remember, we wanted the x-axis, we want to go from -10 to 10. Well, so to create a line, all you need in this case are 2 points, because it's a straight line. You just need to define 2 points and it will automatically create the line. So we don't need that many values here. So x can really just be negative 10 and 10. And that's all we need for x. As long as we have negative 10 and 10, we can always draw a straight line between those 2 points, and it will be the correct straight line. So that's all we need. So y in this case, what would y be? Well, so we know y is going to equal, as we specified over here, it's going to equal mx plus b. And we already got m and b, so all we have to do is multiply x by m and add b. And this is exactly what that function is going to be. Y equals m times x. X is specified, and once again, when we multiply and add, if you remember the mathematic operations for vectors, it's going to automatically do this to every single value in our x vector. So we're going to get our y vector. So now in this case, we can simply, well, let's actually add a comment in here before I forget. Calculate the y values. And down here, we're just simply going to plot the function. So let's actually begin plotting this. So we're just going to simply use plot. We can say plot x comma y. I'm not going to be too picky about the color or anything right now, so we're just going to say plot x comma y. Let's see, what else do we want to put in here? Let's put an x label. So x label is just going to be x. Y label, just going to be y. Title for the plot, let's say custom linear plot. Because this is just a custom plot, the user can choose what they want for m and b, the slope and y-intercept. And then let's turn the grid on, because why not? And this should be everything we need to make it. Notice how we were able to use our input, our knowledge of input and output with the user in the command window to actually do something with a plot. So let's save this and let's try running it. And I'm going to delete this before I run it. Let's say custom plot. So enter value for the slope. Let's make the slope 4. Enter value for the y-intercept. Let's make it 2. So it actually does exactly that. So we can see here, negative 10 to 10. Though that's where our x value goes from, and our y value stretches all the way from negative 40. Well, it looks like a negative 38 probably, all the way up to probably like 41 or 42 in this case. So we can see we actually made a custom plot in this case. It graphed this linear function, this linear line, and shows us all the values in between. Looks like our y-intercept is in fact 2. The y-intercept would be right here because that's where 0 is. Or that's where x crosses 0 in this case, actually. And it does about equal 2. So this worked the way we wanted it to. So that's how we would kind of use input in this case. You're not really going to use input all that much with plotting. Generally, you're just going to plot. I figured this would just be a cool way to kind of use some of the skills we've learned in previous videos to make a plot and write a script with it. So now plotting multiple curves at once. So we can actually put more than one curve on a plot at once by using this key phrase known as hold on. In order to plot the two curves at once, simply plot the first curve using the plot function, type hold on, and then plot the second curve once again by using the plot function. Plotting multiple curves at once allows then for the legend function to have more of a purpose in this case, because we didn't look at legend earlier, but now we actually have a reason to. So the legend function can be used by entering the names of the plots in order in which they're plotted in the script. I'm going to show you exactly how we do this purely through an example. So we're going to plot the curves sine of x and cosine of x on the same graph. So let's see how we'd go about doing this. So I'm going to create a new script in this case. Let's save it. We're going to call it sine and cosine. Simple as that. The purpose, this script will plot the functions sine and cosine on the same graph. All right, simple as that. Now the first thing we're going to do is, let's define points for x and y axis. So we're going to have two y axes in this case. One of them is going to be for sine of x, the other is going to be for cosine of x. So let's see how we're going to do this here. So let's do the same 50 points that we did previously. So let's go from 0 to 2 pi using 50 points, kind of like we did a couple examples ago. So it'll be linspace 0, 2 times pi, and we're going to do 50. So we're using that linspace function. So we need two different y-axes here. So I'm going to name one y1. y1 is going to be, in this case, let's make my y1 the sine of x. So I'm going to say sine of x. And that's all I have to do. That's going to give me a vector with all the values of sine of x that I want. So then I'm going to make y2, because we're going to plot cosine also. So it's simply just going to be cosine of x. Once again, this is going to give me a y vector in this case, for all the values of the cosine of x. So we've defined all of our x and y axis. So then first, plot the first function. So we're just going to do exactly that. And all we have to do is just say plot. Let's see what values we want here. So we're going to say x, comma, y. Let's plot the first one in blue. So we're going to plot sine in, actually let's plot sine in red. So we're going to plot sine of x in red. Notice here I put y, that shouldn't be right. Since we're plotting sine first, we're going to use y1 because y1 is the corresponding y vector with sine of x. I'm going to close that. So then I need to actually use the hold on key phrase in here so that MATLAB knows to not plot this second one in a new figure. We're going to plot it in the exact same figure. So I'm going to type hold on. And that's all I need to type in this case. MATLAB will automatically know that, okay, I'm expecting another plot in this case. And the plot will be put on the exact same window, the same figure. So let's plot the second function. Plot x comma y2 in this case. We're doing y2 because y2 is the cosine of x. And let's plot the cosine in blue. Final thing we're going to do is customize the plot. So to customize, let's see, we got our x label. X label is simply going to be x. Y label, simply going to be y. All right, what else should we put? Let's put a title in here. And that title is simply going to be plot of sine of x and cosine of x, since we're plotting both of them. Let's let whoever's reading this graph know it's going to have both of these on here. Now in this case, though, we can actually add a legend. And the legend works by adding, in this case, we need to add two separate values because we have two different plots. If we only put one value in here, MATLAB's going to get kind of confused. But since we have two separate plots, we can put two values in for legend. So for the first one, let's put, since the first one is the sine, let's put sine. And for our second value, it's cosine. So let's put cosine. This is going to give us a legend, and you're going to see what this legend looks like in just a second. And let's turn grid on, just because. And this is all we need to type in this case to actually make this work. So let's save it, and then let's see if this actually gives us what we'd expect. All right, so let's see what we got here. So as you can see, the red one is supposed to be sine. Let's look at the legend first. So right here, this is what I mean by a legend. So it gives us a red line, and it says sine. It gives us a blue line, and it says cosine. This is just to tell us, okay, the red line's sine of x, and the blue one's cosine of x. So let's look at that red one. Sine of x does in fact start at 0 when x equals 0, and it seems to be going in a sinusoid, and that's what we'd expect. Cosine, when x equals 0, is 1. When x equals pi is 0, it works the exact same way. So we were able to plot both sine of x and cosine x on the same graph, and it looks pretty nice in this case. We have the grid on, and everything looks pretty convenient. It makes it a lot easier to plot multiple curves at once, and MATLAB does this very easily. All we had to do is type hold on, and it worked pretty darn well. All right, the next topic we're going to look at is using file input with a .dat file in MATLAB. So one can save specific numerical values to one's personal computer by saving the value to a .dat file. Essentially, if you have a lot of data that you want to save, and you want to save it as a variable, but you're afraid when you close your computer, MATLAB is going to erase the variable and all that. Because remember, once you close MATLAB, all your variables over here in your workspace just disappear once you close MATLAB. But if you want to save certain values, or if you want to save a matrix of values, you can do so with a .dat file, and it will be saved on your computer, and you can load them so you can use them later. So for example, one could create a matrix of random decimals starting by stating mat equals rand3. So let's start doing this. So I'm going to exit out of here. I'm going to clear all my variables for now. So let's start from scratch. We could say mat equals, remember the rand function will create random decimals, a 3x3 matrix of random decimals, which is exactly what we see here. So let's say we want to save these values. How are we going to do that? So this matrix can be saved to a .dat file using the save function. So we're going to use this notation. Type the word save, type the file name that you want, so filename.dat. We're going to give the word mat, because mat is the name of the matrix we're dealing with. Then we need to type this little tag here. It's -ASCII, or ASCII. And ASCII is essentially saying, okay, we have numerical values in here, but when we save them to our .dat file, make sure they're actually saved as numbers in this case. It's just so MATLAB knows that this data is numeric. So it must be used when creating a data file, or else it's not going to work. So let's actually try this. So if I want to save this variable mat to my computer, and it's going to show up along here. I can say save. Let's say I want to call it test file. So this is my file name, testfile.dat. The variable I want to save is mat, so that's going to be my second value here. And then I need to type the -ASCII. Let's see what happens here. So you'll notice over here to the left in my current folder, I have a new variable down here, testfile.dat. If I select this, something should show. Yep, this showed up in a new window, and it's actually going to show all the values I have entered in here. And this is in scientific notation. If I hover over, it's actually going to show all this. So these are the values that are stored in this dat file. So, okay, that's cool. Yeah, it's on my computer, but so what? Well, so what is that if a dat file is already saved into your current directory, one can access the numerical data by using the load function. So I can say load, then type the name of that file, and that variable is going to show up in MATLAB. So let's see what I mean. So let's clear this variable we have here. So if I say clear mat, so that variable's gone now. We don't have that variable. If I try accessing mat, it's not going to work because it's not defined. So let's get over here. Now let's say I want those exact same numbers again. I can't just use rand of 3 again because it's going to give me 3 random decimals. So in this case, I can use the load function. If I type load testfile.dat, you'll see over here in my workspace I have a new variable test file. Let's see what happens if I type test file. It's the exact same 3 values that we started with. These are the same 3 values, so I can actually access these even though I deleted that variable earlier. If data is already saved to a file, one can append more data at the end of the file using the append flag. Save file name.dat, nuvec.ascii, and then you put this other flag .append if you want to add new data at the end of your test file. So let's see what I mean. So we have this data in here. Cool. So I want to save this data, but I want to add 3 new values at the bottom. Let's say I want to add this vector at the bottom. I can say vec, let's do 0.1, 0.2, 0.3. So I want to add this vector at the very bottom of this matrix here, and I want to save it. Here's how we would do it, and actually we can go back to see it. So save file name.dat. The new vector, or whatever matrix, whatever you want to append at the end, the variable goes right here. Then you say ASCII, then you say append. So let's do just that. So I'm going to say save. I want to save it once again, this test file.dat, because it already exists. The vector I want to tag at the end of it is just vec, as you can see right here. I have to put ASCII. And then since I'm appending data at the very end, I'm going to say -append. So let's see if this actually works. Let's clear our variables over on our workspace. So they're gone now. CLC, so test file no longer exists as a variable. So let's load the value again. Load testfile.dat. You'll see test file appeared over here. Now those 3 values are appended at the bottom. This worked exactly as we expected it to. Everything's nice. We have our previous 9 values along with the extra 3 appended at the very end. This is how we can append data to a dat file specifically. The last thing I'm going to touch on, we're just going to do a really quick example, is using the .dat file for plotting. If information is saved in a .dat file on the current directory, one can use the information in the file to create multiple plots. For example, each row of the .dat file could be used as a separate set of y values for the plot. In the script for plotting, use the load function to upload the data as a variable, use the data for the plotting, use the hold on key phrase to use multiple plots, multiple curves at once. There's a lot of random stuff I said, but in theory, we're just combining the 2 skills that we learned previously. So let's see what I mean by that. Let's clear our variables. Let's delete this test file over here. So we no longer have that. Oh, it's got to delete that. So let's create some data for us to use in a plot. So let's say I'm going to label this plot data. I'm going to make a little vector for us here. So let's say, okay, what kind of data should I have here? Let's just do some random decimals. So let's say, let's see, we have 0.45, 0.34, 0.78, 0.23, comma, actually no, semicolon, 0.12, 0.78, 0.22, 0.90. So let's say this is some data we have here. Let's say these are, I don't know, percent averages different classes have on quizzes. 12% and 22% and 23, not too good. But let's say that's what it is. So this is different data for the average scores. And let's say this first row is class A and this second row is class B. So these are the different test averages that we have for class A and class B every quarter. So let's say we wanted to plot both of these data on separate curves. We could kind of use what we've been doing here, but let's say we don't want to type all this in our script. First, what we can do is we can save this to a .dat file. So I can say save plot data.dat. That's gonna be the name of my dat file. The variable we're dealing with is named plot data. And then I want to specify that it's ASCII. So then you can see here, plot data is a new .dat file in my current folder. That means since it's in this folder, I can create a script and I can use this data. So let's create a new script. I'm gonna call it test average plot, something like that. Plots the values for test averages of two classes in on the same graph. Let's do that. So the first thing we're going to do is we need to actually get the data that we're going to, well, use in this case. So I can say load the data from the .dat file. So the first thing I'm going to do immediately is just say load, and then in this case I'm going to load plot data.dat. So if I do this, it's going to create a variable called plot data, and I can use that data how I want to. So first, let's then, well, actually second, I guess, let's create X and Y vectors for our plots. So let's create the X one first. So since this is going to be the test average for each quarter, it would make sense for X values to be 1, 2, and 3. Well, 1, 2, 3, and 4 in this case, because we have 4 different quarters, 4 different values. X can just be 1, 2, 3, and 4, because those are going to be the 4 quarters that we're going to be looking at here. Because remember, these are test averages for separate quarters. So let's say X goes from 1 through 4. If you're not familiar with this notation, once again, I'd recommend looking at my matrices and vectors video here on YouTube. Then we're going to create our Y and, well, our two Y axes. Because remember, we're making 2 separate plots on the same graph. So instead of calling it Y, let's make it something that makes a little more sense. So I'm going to call the first Y-axis class A, because that's how I'm representing this. This is going to be class A, this is going to be class B, and these are the 2 different test averages for each of them. So class A is going to be, well, class A is going to be the first row of data. So how do I access the first row of data? We're going to use some of our matrix indexing techniques in this case. So the variable that all of this data is saved under is plot data, but I only want to get the first row. If you remember, for indexing an entire first row, I need to use 1, colon. And that's going to give me the first row of data in plot data. Class B, similarly, is going to be the second row of data. So I'm going to say plot data 2, colon. These are going to give me my y-axis data. So now I can actually plot the data. So plot class A data. That's going to be the first data I plot. So to do that, I'm simply going to use the plot function. X is going to be my x-axis. My y-axis is going to be represented by the variable class A. So instead of putting a y in here, I'm just going to put class A, because it's the same thing. It's the vector that I want. It's a vector of 4 different numbers in this case. And then let's put class A in red, like we did last time. Now I have to use hold on. Now I'm going to plot class B data. So I'm going to use the plot function once again. And we're going to use X once again, because I want to use 1, 2, 3, 4. But this time I'm going to use class B, and then let's make it blue. Then we can customize the plot. So first we can add an X label. In this case, the X label isn't going to be X. It's going to be whatever quarter we're looking at. So we're going to call X-axis the quarter, because we're looking at 4 separate quarters of test averages. The Y label in this case is going to be the test average. So we're going to say test average as decimal, because these aren't percentages, they're decimals, just to specify to whoever's reading this graph. Title, we could say the title is going to be test averages of class A and class B. We also want to create a legend in this case, because we have more than one plot we're looking at. So legend, the first one's going to be class A, and the second one's going to be class B. So we're using our legend to specify the 2 different plots. then in this case, let's not include our grid actually, just because it's not really something we need our grid for. So now we're going to save it. Now let's see if I actually run this here, if it all works as expected. So this actually works how we want to. Class A, if we remember, look at these points here, it was 0.45, 0.34, 0.78, 0.32. Looks like 0.45. Looks like all the numbers match up for Class A. We can see Class A is in red. Class B is in blue, so 0.12 looks like it starts there, goes to 0.78, goes to 0.22, goes back up to 0.90. So this data is used exactly as we expect it to. We can see our X and Y label here, we can see the title, and it's plotted in a way that's very nice and didn't honestly take all too much work. We could save data down here in our command window, but instead of typing all the data out, let's say we had hundreds of different points or thousands of different points. That'd be too much to type all at once. But instead, if we saved it all beforehand into a .dat file, we could just load it from the data file and parse information from there. And it makes everything very straightforward and very easy. All right, thank you so much for watching. I hope this tip on plotting and using .dat files definitely helped.